Hello everyone, welcome to this video. My name is Amir Senahari, I'm a Google Earth Engine expert. In this video, I'm going to show you how to estimate NDVI changes after flood. Actually, the main goal is to highlight vegetation changes after the flood in our study area. Let's get started. Go to the code editor in the Google Earth Engine platform. Unfortunately, in 2019, we had a severe flood in the north of Iran, and also in the previous tutorial in my YouTube page, I showed you how we can highlight the flooded region by the radar data. If you didn't see that video, you can go to my YouTube page, and the previous video, Google Earth Engine tutorial number 6, is useful video that's showing how we can highlight the flooded region by the radar images Sentinel-1. It's very useful for this tutorial. But here, now I'm gonna show you how to assess the changes occurred in the NDVI after flood events, after the flood events actually. So for the first step, we need to go to the study area. My study area is a part of Gulistan province in the north of Iran, and then after location of interest identification, we can go further for the processing. So here I wanna select a short region in my study area. So here, as you can see, this is a part of province that was under the flood condition. It was a very severe condition and caused a lot of damage for the people and croplands in this area. Actually, we want to show how vegetation and how much vegetation changed after flood events in this region. So for the first step in the scripting, now we need to focus on the study area by map.center object. So the map.center object, inside it we have geometry. So then make a new variable to call Landsat 8 data. We want to make a monthly mosaic of Landsat, one of them 1 month before the event and another one 1 month after the event. So accordingly, make a new variable, for example before, equals to, through the search places and dataset, try to find Landsat 8 collection 2 level 2. Actually, the Landsat 8 data collection 2 and level 2, all of them processed correctly, all of them corrected geometrically and radiometrically. And now in this tutorial, I'm gonna use them to calculate NDVI and make a monthly mosaic and estimate the NDVI changes. So here we have Landsat 8 level 2 collection 2 imported into the code, and here entitled as an image collection in the above bar that you can see. So image collection assigned to the before, and then we need to define the filter date and filter bound. That filter date equals, or filter date inside the parentheses, we need two variable, time start and time end. Before that, we make a new variable, time start equals to the flood event occurred in 2019, so time start 2019, and time end would be 2020. The flood event occurred in the March 2019, so 1 month before is February 2019, and 1 month after is, for example, April 2019. So then make a filter bound to narrow down Landsat images to a specific location already defined by the rectangle. Filter bound geometry, bound the data by the geometry, and then in the next step we need to set a month filter. So here define a new filter, earthengine.filter.calendar range. Calendar range is very useful temporal filter, enable us to filter the data based on hour, based on day, based on month, or even by year. And also it's very helpful tool actually to filter data based on time characteristic. So here we have February as a start month and February as an end month, and the unit will be month here. And then we need to get the median of all Landsat data available in this region, and then we need to apply the scale and factor that is already prescribed by the description. Actually, as you can see here, the data provider from the USGS, NASA, and Google here mentioned that before using Landsat data collection tool level 2, we need to apply the scale and factor. The scale is this, and factor or offset is minus 0.2. So back to code, and here paste the scale and add the offset 0.2. But as we want to estimate the NDVI first, we need to select surface reflectance band. I want to select those of bands starting with SR, and the rest of them it's not important, just all of the bands, surface reflectance bands started with SR, meaning surface reflectance is enough. So for this part. So in the next part, I want to get a print to see that if I had any problem in the programming or scripting so far or not. Just print before image for February. In the right panel, you can see we have one image with 8 bands, but we only want to use a near infrared band and the red band to calculate the NDVI, and the rest of them we don't need the rest of them actually. So here make a new variable NDVI before or NDVI February equals to get the Landsat before images. Using normalized difference, we can get the normalized difference between near infrared and the red. The near infrared is band number 5 and the red is band number 4. If you don't know which bands consisting red wavelengths or blue wavelengths or near infrared wavelengths, just go to the description, and here the wavelengths are available. For a remote sensing expert, it is necessary to know that which wavelengths belong to which part of electromagnetic spectrum. For example, as a remote sensing expert, we know that, for example, 0.4 belongs to blue region, or 0.5 belongs to, for example, green region, and also 0.8 belongs to near infrared region. Also, it's important to know before doing any processing, because if you don't have such kind of information, when a new satellite launched, you cannot deal with the bands because you don't know which bands working in which kind of application. So you will get confused actually. So here we have NDVI for the before, 1 month before the event. To visualize the NDVI before, let me correct this. Map.add layer help us very easily. So NDVI before, just clip it based on the region of the interest. I leave the visual characteristic empty. I want to have a grayscale image of NDVI for 1 month before. And then for the layer setting name, we can write the name of the layer. For example, this is NDVI before, or just we can say, for example, before event. You can choose whatever, you can choose every name that you want actually. So, and then we will have false here to avoid automatic visualization. And now run the code, and after a few moments, by check the before event, you can see the image before the flood event actually. And here, as you can see, we have a normal situation in our study area. And as you know, in the NDVI images, the white area showing the croplands. How we can say this area is cropland? If you go a little in depth based on the pattern in this region and based on the Google image we have in the background, for sure we can say that here is full of croplands, and we want to see that after the flood events how much how much the croplands changed because of the situation or because of the disaster or natural disaster that occurred in this region. So now we need another image for the after event. So just copy all of the code into the next part. Here you can see that just I copy the before code to a new line, but here we need to change something. Instead of before, we will have after, same image collection, same bands, same filter date, and filter bounds. But here, the calendar range should be shifted to 1 month after the event. The event was in was in the March, and now we are 1 month after will be February, for example, month number 4. And also keep the scale and factor same, no need to change. And here we will have NDVI after, and take the after image dot normalize difference with the same bands, and for the map.add layer we will have NDVI after dot clip, and the name for the layer setting will be after event. So save your code and then run it. After a few moments, here we have a before event image. I want to visualize them at the same time. So with a kind of stretch, you will have a better visualization. And then the after event, the area changed like this. But this part, unfortunately, we have a gap in our study area. No images were available for this part, and also then we face with a kind of error in this part after getting median images, and also should be considered and also pay attention to the median is very important when you use the median in your code to collect all of the images or aggregate all of the images in 1 month in a single data frame. The median helps us to reduce the amount of the noises. Unfortunately, sometimes such big gaps in the satellite data, we cannot resolve such kind of problems by median, mean, or maximum or something like that. But as the sale mainly occurred in this region, we can remove this part from our study area to have a better visualization for the further steps and to avoid any misunderstanding in the final interpretation. So accordingly, I make a smaller area for the region of interest just to escape from the noises after temporal aggregation. Yes, there it is. And then I run its code, and here you can see that before events, and then we have after events. You can see that the after event, most of the croplands influenced negatively, and also the urban area negatively influenced by the flood situation. And as you can see, the rate of NDVI clearly decreased after the event here. In the last tutorial number 6 in my YouTube page, I showed you how we can identify the region of the flooded area by the radar images. But here I want to help you to estimate the rate of changes based on the percentage in the Google Earth Engine platform using the optical imagery, because in the radar images we can't see the croplands very well, very clear, such as NDVI, but that's why I prefer to use NDVI and optical images to highlight vegetation changes in a study area. And as NDVI is a global index in all around the world, you can use this index to estimate the changes for the regarding to the vegetation condition and also for the water and other phenomena such as soil. But for vegetation and water, this index provides the higher accuracy. So in the next step, we want to estimate the rate of changes between the image before and image after. So here, just I make a new variable like this, change percent equals to, so to get the percent of change between two values, there is an equation. I want to get the percent of change like this, equals to, we have one old and one new image. The before image is old and after event is the new image. To get the percent of change, we need to apply this equation. The new image minus or subtraction between new and old image over to old images multiply 100. As you can see, multiply 100. So just we need to write this equation based on NDVI after and NDVI before. To do this, it's very simple and there is no big deal. Just we have NDVI after here, NDVI after dot subtract minus NDVI before, and then I put this expression into a parenthesis, and then the result divided or over NDVI before multiply whole expression to 100 points. So here by map.add layer, I can visualize change percent. Just remember to clip it based on the geometry or the location of the interest. I leave the visualization empty here, and its naming of layer setting will be NDVI change based on percent. When we turn the changes to a percent for the interpretation, it's very easy to talk about the changes, and also it is most concrete results when we talk about the percent of changes. So, and at the end, to avoid automatic visualization, I use false expression here and then run your code again. So here we have a problem, line 30 here, change percent dot clip geometry, change percent dot clip is not a function. So let's see what's the problem. For example, first I want to print change percent. It is none. It means there is something wrong in our computation. So let's try again. I think the problem here is about the multiply sign. In the Earth engine, when we use something like subtract or divide, for multiply is same. So we need to correct it like this, dot multiply 100. So now I think the problem is gonna be solved. Yes, the problem is solved, and then try again for the visualization. So this is NDVI changes, and as you can see here, the percent of changes and the direction of the changes will be shown from by a grayscale images. So here, as you can see, the darker regions, very dark regions in this area, showing that we had a negative change, and also the brighter region showing there is a positive changes. And also that's important to know that after the flood, for sure we know that the rate of NDVI changed definitely. So these areas that are matched to the flood region with a negative value or with a darker region, showing that the amount of NDVI decreased, or vegetation covers, whether it is cropland or rangeland, all of them destroyed in this region. But if you want to know about the rate of the changes, using the inspector, you can get all of this information. If I click on here, you can see that we had minus 159% changes from before to the after. Before the event, the NDVI in this region was 0.5, but after the event, it's reduced to minus 0.3 in the NDVI images. So here, by this image, you can see first the direction of the changes. Positive means increasing, and the negative means decreasing. So here we know that the NDVI decreased, and also the intensity of change also showing by the magnitude of the number. For example, 159 showing that the rate of changes is very higher than this area with, for example, minus 85%, meaning that after the event, the rate of vegetation cover in this pixel reduced by minus 85%. And also we can set some threshold to see only the vegetations that changed after the flood. For example, I make a new threshold here. For example, change threshold. We need to have access to all negative changes, vegetations that's down after that turned down after the flood events, equals to, here I can set a threshold to get change percent images and select those of pixels that are lower than or less than 0. Just we want to consider the positive values. And if we have change mask, another variable is change mask that gets the change percent and update mask and apply an update mask on based on change threshold here. And by the map.add layer, you can see here we have a change mask and dot clip based on the geometry, and leave the visualization empty. The name is vegetation changes, and finally we will have false here. So here you can see only the regions in which NDVI decreased from before event to the after events, or those of regions that affected by the NDVI values, actually affected by the flood, and their NDVI significantly changed. So using the apply, you can see that those of regions with the with more severe change appear with a darker color. For example, here, if I click on this region, you can see that only we have everywhere on the image. When you select it, you can see that the rate of the NDVI changes, showing the negative changes in the NDVI final images, and also as much as the final value lower, you can see that the intensity of change was higher. So this is the tutorial about how to detect the NDVI changes regarding to the flood event in the study area. And also this code gonna be useful for all around the world. Wherever in the world that a flood event occurred, you can compare 1 month after and 1 month before, or a few days before and a few days after, and check the NDVI changes by this technique, and to interpret the severity of the changes occurred in your study area. If you had any comments or problem during the programming steps, just feel free to contact and put the comments in my YouTube page. I will glad to help you.